Hmm. Welcome back. Today, I want to talk about quadratic functions and what's called standard form. Explain what that means. So, our goals, as we see, is to be able to find the important values of a quadratic function when it's in this form, and also be able to graph a quadratic function in the standard form. So, now let's take a look here. This is what we call by a standard form. So, once again, this is a quadratic function because the highest power of x is squared. And so, this, unlike the vertex function of form, this one has this particular form, as it says, ax squared, some square term plus some single variable term plus some constant. And the only one that for be a quadratic function, the only one that has to be there is this first term. You can be missing this one or both. To be quadratic, the highest power has to be x squared. And if you're familiar with the quadratic formula for solving quadratic equations, these are the same a, b, and c as you see in that form, in that formula. So let's look at a few of the details. The graph of a quadratic function is a parabola, and that's true of any quadratic function, no matter what form it's in. From this form, it's very easy to find the y-intercepts. Just plug in 0 for x, and these terms go away, and all you have left is c. So the y-intercept has coordinate 0, c. The vertex is harder to find than it is in the vertex form. Basically, you have a small formula. So the x-coordinate is given by this formula, negative b over 2a. Once again, it has this a and b, as you see, or the b is determined from the single variable term. So the b is a coefficient from the single variable, and the a is a coefficient from the squared variable. And then once you find that, that's your x-coordinate, you plug that in to find your y-coordinate of your vertex. Now, the x-intercepts are found by setting fx equal to 0. So set this equal to 0 and solve. It's possible you may have to use the quadratic formula. That will solve any quadratic equation. But you can also, it might factor in some cases. But if these solutions are not real, or see if they involve have a negative number in the square root anywhere, if they involve complex numbers, then there are no x-intercepts. Now, if the parabola has x-intercepts, the x-coordinate of the vertex found by this formula is halfway between the x-coordinates of the x-intercepts. That's because of symmetry. Now, if a, this number in front of the squared term, which if you're familiar with the vertex form is the same a, if it's positive, your parabola opens up. If it's negative, your parabola opens down. And also, if the parabola opens up, the y-coordinate of the vertex, this is a minimum value. That's the lowest value of the function. And if it opens down, this is a maximum value. The y-coordinate of the vertex is a maximum value if it opens down. And finally, the parabola has an axis of symmetry, which is a vertical line that runs through the vertex and has the equation x equals the x-coordinate of the vertex. So let's take a look at an example and see if this works and be able to graph it as well. So let's look at this first example. Okay, so number 1 is going to be, excuse me, I want to find where I wrote that. F of x is equal to x squared minus x plus 6. Okay, so we can find out about it. So a few things. So our a, let's just go and find a, b, and c as you would if you're finding or solving the quadratic formula. So a is a number from the squared term. It's going to be 1 in this case. B is a number from the single variable. That's going to be negative 1. And c is the number by itself, and that's 6. Now, of course, once again, a, as we see, is 1, is greater than 0. So it means that tells us that this parabola opens up. Okay, now, let's also find the y-intercept. Okay, so the y-intercept, I give you right here, but where this comes from, 0c, we know c, is basically you plug in 0 for x, that's your input. Of course, it'd be 0 squared minus 0 plus 6. Those go away. Of course, that's just equal to 6. So the coordinates of your y-intercept are 0 and c, 0, 6. Now, actually, give me a moment. I have to add some space. So just a moment. Okay, so that's the y-intercept. Now let's find the x-intercept or x-intercepts. Okay, so we do that. Here we're going to solve f of x is equal to 0. So we take our quadratic function and set it equal to 0. So that means we want to solve x squared minus x plus 6 is equal to 0. Now this one, we could, of course, use the quadratic formula, but also complete the square. But here, this one will actually factor. And this one factors into x minus 3 and x plus 2. Actually, I'm sorry, it doesn't. I need to make a correction. Apologize. So this should be a negative. So hang on. That changes a few things. So this also should be a negative. I apologize for that. Fix that here, here, and also here. Because actually what I wrote would not factor it. It does now. Well, I need to fix it here. So as to what I wrote actually wouldn't factor if we didn't do that. Okay, this does factor. So remember, when it's in factored form, for this to be 0, either this factor or both have to be equal to 0. So you set each one equal to 0. So you have x minus 3 is equal to 0. X plus 2 is equal to 0. And so solve each one. We have x equals 3, x equals negative 2. So we have two x-intercepts. Okay. So these are the x-coordinates. So one x-intercept is going to be 3, 0. The other one is negative 2, 0. And we'll graph those below. Okay. And since we got a real solutions, it means we do have to have x-intercepts. If we'd gotten anything imaginary, anything involving I, the square root of a negative number, or I, then we would not have x-intercepts. Okay. Also, we can say that a few more things. Since the parabola, it does make a parabola, opens up, then y equals the, actually we haven't found our vertex yet. So actually, let's scratch that statement. Let's find this next. Let's find our vertex. So to find the vertex, the x-coordinate is equal to, we have this little formula, negative b over 2a. Now, those are the same b and a we found up here. So a was 1 and b was negative 1. So we plug those in. Now here, remember, this negative here is part of the formula. Then b itself was negative and a was positive. We have a 2 here. Okay. And so if we have that, the result's going to be positive. It's going to be positive 1/2. Okay. That's the x-coordinate of our vertex. Now, to find the y-coordinate, you have to plug that in. The y-coordinate is going to be f of 1/2. So you have to work with fractions a bit. Let's go down here and do that. So f of 1/2 is going to be 1/2 squared minus 1/2 plus, or sorry, minus 6. Okay. So continuing. So 1/2 squared, you think of it as squaring the numerator and denominator separately. Of course, 1 squared is 1, 2 squared is 4, minus 1/2 plus 6. Now, remembering how to combine fractions, different denominators, you need a least common denominator. Actually, any common denominator, but least common denominator will be 4. So we need to put each one of these as a fraction over 4. This one's already over 4. So we have to do now then, I'm sorry, it should be a minus 6. I keep forgetting it's a minus, not plus. So I need to write 1/2 as something over 4. So I need to multiply the top and bottom, what I need to multiply 2 by to get 4, which is 2. Let's multiply 2 by 2 to get 4. So we multiply the top and bottom by that number. Here for minus 6, the thing is being 6 over 1. And here I want a denominator once again of 4. So the only way to get that is multiplying 1 by 4. So multiply the top and bottom by 4. Let's put all this together. So 1/4 minus 2/4 plus, minus again, 24/4. Okay, combine those using order of operations from left to right. And so 1/4 minus 2/4 is a negative 1/4 minus 24/4. A little more space. And that's going to be negative 25/4. And that should be approximately negative 6.25. Okay, so the vertex has the coordinates 1/2, positive 1/2, and negative 25/4. Okay, now we can also say at this point, which I was about to write in a moment ago. Okay, let me get rid of this for the moment. Is that since this parabola opens up, we found that because our A was positive, then the y coordinate of our vertex, y equals negative 25/4, is the minimum. It's the minimum or the lowest value the function takes. Okay, and then I think our final step is this axis of symmetry. Is the vertical line x equals to, and the whatever the x coordinate is. Remember, vertical line is the equation x equals something, so x equals 1/2. Now, let's take all of this and graph it. And I'm going to enlarge this slightly so we can get a better view. There. Okay, so our vertex is going to be 1/2, so basically 1/2 and about negative 6.25. I have to approximate that. So 1/2, positive 1/2 is about right here. Negative 6.25, that's going to be just about right there. A little hard to find. So 1/2 and negative 25/4. That's our vertex. Okay. Now, let's also find our x-intercepts. We said those were at 3, 0, and negative 2, 0. So negative 2, 0, and 3, 0. And 3, 0. And then we also had our y-intercept. And our y-intercept, I believe, was 0, negative 6. Oops, I realized I forgot to make that negative. 0, negative 6. Actually, it's just right there. So if you graph this, it looks something kind of like this. Once again, you can verify this on a graphing calculator or another graphing website. Last thing, we have an axis of symmetry that comes right through the middle, divides the parabola in half. And the parabola is a mirror image on each side of the axis of symmetry. The axis of symmetry, we just said, is this line, x equals 1/2. So let's take a look at what we learned. So what we learned is that basically from this, what's called the standard form, we can find all the same things you could find using the vertex form of a quadratic function. We can find, of course, we know it's a parabola. You can tell which opens up or not. We can find the vertex, the x-intercepts, the y-intercepts, the minimum or maximum values, and the axis of symmetry. We can find all those, and we can actually use all those to graph it by hand. And so we met both of our goals by being able to find those important functions, also being able to graph it. Thank you. Have a good day.